Good day, math learners. For this video, we will be talking on the events and their operations as one of the topics for this week. One of the basic concepts in the study of probability is the sample space. A sample space is a set of all possible outcomes of an experiment. In an experiment of tossing a single coin, for example, the two possible outcomes are head and tail. So, the sample space is written in this form. But if a coin is tossed twice as illustrated in the tree diagram, the outcomes are head and head, head and tail and head, and tail and tail. So these are the possible outcomes that we have. So our sample space is written in this form. Please take note, class, that a subset of a sample space is called an event. An event may contain some, all, or none of the possible outcomes comprising the sample space. An event may be a simple event or a compound event. A simple event consists of a single outcome or a single event that cannot be further broken down into smaller events. A compound event is any event combining two or more simple events. One of the examples for compound event is the mutually exclusive events because it refers to two events A and B which are mutually exclusive or disjoint. If they have no common outcomes, they cannot occur at the same time. So this is the illustration of the mutually exclusive events using Venn diagram. The two events A and B are represented by two circles and the sample space S is represented by the rectangle. For example number 1, suppose a die is rolled. Let A be the event that an even number turns up, and let B be the event that an odd number appears. Determine the possible outcomes of events A and B and draw a Venn diagram to illustrate that they are mutually exclusive events. So, here is the solution. Since the given statement emphasizes that the event A is the event that an even number turns up, so set A or the event A contains 2, 4, 6. And the event B is the event that an odd number appears. So, the event B contains 1, 3, and 5. So, our illustration would become like this. We can also describe this illustration as A intersection of B is equal to null set because the two events do not have the same elements. When we were in grade 7 level, our math teachers discussed the basic concepts of sets, which is important to remember this time since our topics relate to this concept. So, let us review on some operations of sets. So we have union of sets. The union of sets A and B is the set of all elements belonging to A or B or to both. The union of sets A and B is denoted by this symbol, and it is read as A union of B. Consider these diagrams. In each illustration, the rectangle represents the universal set. A universal set is a set which contains all the elements involved in the problem. The first illustration refers to mutually exclusive events or disjoint sets in which the two events do not have the same element or no common outcome. The second illustration refers to not mutually exclusive events or mutually inclusive events, in which the two events have the same element or common outcome. Take note as well, class, just for emphasis, that the shaded region in the Venn diagram refers to the outcomes in the experiment. Since set A union of B is shaded, all outcomes found there are considered. For example, number 2, the universal set contains 1, 2, 3, 4, 5, 6, 7, 8. Set A contains 1, 3, 5, 7, and set B contains 2, 4, 6, 8. So, find the elements or the outcomes of set A union of B and draw a Venn diagram to illustrate set A union of B. So here is the solution. A union of B contains 1, 2, 3, 4, 5, 6, 7, 8 since we consider all the outcomes to both set A and set B. And here is the illustration. Both set A and set B are shaded since all outcomes found there are considered. For example number 3, the universal set contains 1, 2, 3, 4, 5, 6, 7, 8, and 9. Set A contains 1, 3, and 5. Set B contains 7 and 8. Now, find the elements or the outcomes of set A union of B and draw a Venn diagram to illustrate A union of B. So, here is the solution. A union of B contains 1, 3, 5, 7, and 8 since we consider all the outcomes that can be found in set A and set B as well. So, here is the illustration for our Venn diagram. Both set A and set B are shaded since all outcomes found there are considered. We put the elements 1, 3, 5 in the first circle because these elements belong to set A. We put 7 and 8 in the second circle because these elements belong to set B. We also put the elements 2, 4, 6, and 9 outside the circle because they don't belong there, but inside the rectangle since they are also the elements of universal set. For example number 4, the universal set contains A, B, C, D, E, F, G. Set A contains A, B, C, D, and set B contains C, D, E, F, G. Now, find A union of B and draw a Venn diagram to illustrate A union of B. So here is the solution. A union of B contains A, B, C, D, E, F, G because we consider all the outcomes of set A and set B. And here is the illustration using the Venn diagram. Both set A and set B are shaded since all outcomes found there are considered. So we put the elements. We put the elements C and D at the center region since they belong to both set A and set B. We put A and B here because they belong to set A only. And we put E, F, and G here because they belong to set B only. So this time, we will be talking on the intersection of sets. The intersection of sets A and B denoted by this symbol. And it is read as A intersection of B, which means the set of all elements common to both A and B. A intersection of P is illustrated in the Venn diagram below. This shaded part is being described by these symbols. So A intersection of P is not equal to null set. For example number 5, the universal set contains 1, 2, 3, 4, 5, 6, 7, 8, and 9. Set A contains 1, 2, 3, 4, and 5. Set B contains 3, 4, 5, 6, 7, 8, and 9. And now, find the elements of A intersection of B and draw a Venn diagram to illustrate A intersection of B. Here is the solution. A intersection of B contains 3, 4, and 5. Since we consider all the elements or outcomes which are common to set A and set B, we have 3, 4, and 5 are common elements because they can be found in both set A and set B. And here is the illustration using the Venn diagram. The center part is shaded only to emphasize the intersection of set A and set B. So we place 3, 4, and 5 at the shaded part because they are common elements or outcomes. We put 1 and 2 here because they belong to set A only. 6, 7, 8, and 9 here because they belong to set B only. So let us have this one. The union of set is the same with the union of events. Since events are sets, they can be combined to form new events by using the set operation of union. The common outcomes of 2 or more events can be determined by using the set operation of intersection. The union of events can be illustrated by means of a Venn diagram. Example number 6. A die is tossed. The sample space contains 1, 2, 3, 4, 5, 6. We can consider the sample space as a universal set. Let A is the event that an odd number occurs. Let B is the event that a number greater than 4 occurs. Now, determine the elements of A and B. Then, find the elements of A union of B and draw a Venn diagram to illustrate A union of B. So here is the solution. Since the possible outcome of event A is an odd number occurs, so event A would contain 1, 3, and 5. And the possible outcome of event B is a number greater than 4 occurs. So event B would contain 5 and 6. And then A union of B would contain 1, 3, 5, and 6 because we will consider all elements or outcomes belong to event A and event B. For the illustration using Venn diagram, we shaded both events A and B here since we are asked to illustrate A union of B. We put 5 at the center or at the intersection part because this element or outcome can be found both to events A and B. We put 1 and 3 here because they belong to set A only. And we put 6 here because it belongs to set B only. The intersection of sets is the same with the intersection of events, in which two events A and B intersect if there are elements common to both A and B. The intersection of A and B is denoted by these symbols, and it is read as A intersection of B. Example number 7. A fair die is rolled. The sample space contains 1, 2, 3, 4, 5, and 6. Let A is the event an even number turns up. Let B is the event the number that turns up is greater than 2. So, find the elements of A intersection of B and draw the Venn diagram to illustrate A intersection of B. Here is the solution. Since the possible outcome of event A is an even number turns up, so event A would contain 2, 4, and 6. And the possible outcome of event B is the number turns up is greater than 2. So event B would contain 3, 4, 5, and 6. And then A intersection of B would contain 4 and 6 because we will consider the elements or outcomes common to both event A and event B. So we have 4 and 4, 6 and 6. For the illustration using Venn diagram, the center part region, which is this, is shaded since we are asked to illustrate A intersection of B only. We put 4 and 6 at the intersection part because these elements or outcomes can be found both to events A and B. We put 2 here because it belongs to set A only, and we put 5 and 3 here because they belong to set B only. So this time, we will be talking on the cardinality of the union of two sets A and B. The cardinality of a set refers to the number of elements of the set. The cardinality of set A is denoted by these symbols: N of A, or the number of elements of set A. For example, let A contains 2, 4, 6, 8, and 10. So, find the cardinality of set A. Solution. Since there are 5 elements in set A, therefore, the cardinality of set A is equal to 5. For example number 9, the sample space S consists of the 6 possible outcomes of a die tossed once. They are 1, 2, 3, 4, 5, and 6. So, the solution, the sample space S contains 6 outcomes. Therefore, the cardinality of the sample space S is equal to 6. The cardinality of the union of two finite disjoint sets A and B is given by the following expression. N of A union of B is equal to N of A plus N of B, or the cardinality of A union of B is equal to the cardinality of A plus the cardinality of B. This means that the number of elements in the union of sets A and B is equal to the number of elements in set A plus the number of elements in set B. For example number 10, the given set A contains A, B, and C, and set B contains D, E, F, G, H. So we are asked to find the cardinality of A, the cardinality of B, and the cardinality of set A union of set B. So here is the solution. We are going to draw a Venn diagram to illustrate the set A union of B. Again, set A contains A, B, C, and set B contains D, E, F, G, and H. Notice that sets A and B are disjoint sets or mutually exclusive events because they don't have common outcomes. Next is to identify the number of elements in set A. So, the cardinality of set A is equal to 3. The cardinality of set B is equal to 5. Then use this expression since we are asked to get the cardinality of set A union of set B, since they are mutually exclusive events. And then substitute the values of the cardinality of set A, which is 3, plus the cardinality of set B, which is 5, and the cardinality of set A union of set B is equal to 8. Example number 11. The sample space consists of 6 possible outcomes, and they are 1, 2, 3, 4, 5, and 6. So let A is the event that an even number occurs, and let B is the event that an odd number occurs. Now we are asked to find the following: the elements of A union of B, the cardinality of the sample space, the cardinality of set A, and the cardinality of set B. Here is the solution. We are going to draw a Venn diagram. Again, set A is the event that an even number occurs. So, it would be 2, 4, and 6. And set B is the event that an odd number occurs. So, it would be 1, 3, and 5. Notice that sets A and B are disjoint sets or mutually exclusive events because they don't have common outcomes. Next is to identify the elements of A union of B based on the Venn diagram. And they are 1, 2, 3, 4, 5, and 6 because they are all the elements of set A and set B. The cardinality of the sample space is equal to 6 because there are 6 possible outcomes as the given stated. The cardinality of set A is equal to 3 because there are 3 possible outcomes in set A, which are 2, 4, and 6. The cardinality of set B is equal to 3 because there are 3 possible outcomes in set B, which are 1, 3, and 5. The cardinality of the union of 2 finite sets A and B that are not disjoint is given by the expression the cardinality of set A union of set B is equal to the cardinality of set A plus the cardinality of set B minus the cardinality of set A intersection of set B. Or, to find the number of elements of the union of sets A and B, add the number of elements of set A to the number of elements of set B. Then subtract the number of elements found in their intersection since these elements were counted twice. Example number 12. Set A contains 1, 2, 3, 4, and 5. And set B contains 3, 4, 5, 6, 7, 8, and 9. Now we are asked to get the cardinality of set A intersection of B and the cardinality of A union of B. Now the solution. Draw a Venn diagram to illustrate A union of B. So here is the diagram. And 3, 4, and 5 are placed here at the intersection part because these elements or outcomes can be found both to set A and set B. We put 1 and 2 here because they belong to set A only. And we put 6, 7, 8, and 9 here because they belong to set B only. As you observe that A union of B is shaded because we need the elements or outcomes in both set A and set B. Next is to identify the cardinality of set A, which is equal to 5. Because there are 5 possible outcomes here. The cardinality of set B is equal to 7 because there are 7 possible outcomes here. Again, the elements of set A intersection of set B are 3, 4, and 5. Therefore, the cardinality of set A intersection of set B is equal to 3 as our answer. So, are we done here? Not yet, because again, we are asked to find the cardinality of A union of B. So this time, we are going to use this expression. Since we are asked to get the cardinality of set A union of set B, and the circles in the Venn diagram are overlapping, or the sets A and B are having common outcomes. And then, substitute the values of the cardinality of set A, which is equal to 5, the cardinality of set B, which is equal to 7, and the cardinality of set A intersection of B, which is equal to 3. Then simplify, and you will be getting 9 as our final answer. And we can also base our answer on the diagram. Since A union of B here contains 1, 2, 3, 4, 5, 6, 7, 8, and 9, therefore, there are 9 elements in their union. Thank you for listening, math learners. I hope that you will answer all the activities that we have prepared for you. Keep safe and God bless always.